Fourth grade, we've come to the end of Module 5, so today we're going to be doing 2 review sheets in our notes. So your next 2 pages are 78 and 79, and we are doing a Module 5 review. Take your time to fill out your table of contents, pause the video if you need to, and then let's get going. So we have all sorts of tasks that we're going to practice today. We're going to be comparing fractions, adding fractions, subtracting fractions, multiplying fractions. So we're going to be all over the place with our skills today. The first 2 things we're going to practice is comparing fractions, especially comparing fractions where one is a mixed number and one is improper, or perhaps if they have different denominators in different units. Let's start with this one. We have a mixed number compared to an improper fraction. For us to be able to compare them, they either need to both be mixed numbers or both be improper fractions. I have more practice turning an improper fraction into a mixed number, so that's what I'm going to do. I'm going to change 29 thirds into a mixed number like I have with 9 1/3. I want to see how many groups of 3 thirds I can pull out of 29 thirds without going over. Now, I could pull out 3 thirds at a time, but if I know I skip count by 3s, it's going to take me a while to get to 29. A more efficient strategy would be to ask myself, when I skip count by 3s, what multiple gets me the closest to 29 without going over? 3, 6, 9, 12, 15, I gotta keep going, 18, 21, 24, 27. 27 is the closest I can get to without going over, which leaves me with just 2 more thirds. So if 29 thirds was a mixed number, it would be 27 thirds, which is, let's count up how many groups that was again, 3, 6, 9, 12, 15, 18, 21, 24, 27, also 9, and our leftover fraction, 2 thirds. Now this is much easier to compare. The hungry alligator eats the fraction that is greater. So would the hungry alligator rather have 9 1/3 or 9 2/3? If you said to yourself 2 thirds, you are correct. We're going to point that mouth towards 29 thirds. Next, we have 2 numbers. They're both improper fractions, so that's great. That saves us the step of having to change one of them into a mixed number or the other into an improper fraction. They're both stated that way. But they have different denominators. We have sixths and we have twelfths. To make them the same denominator, we have to ask ourselves a question. Can I skip count by one of my denominators to make it to my other denominator? Meaning, could I skip count by 6s and make it to the number 12? I can actually. I can skip count by 6 2 times to turn it into 12ths. So let's change our 12 sixths into however many 12ths we'll come up with. Our missing factor is 2. 6 times 2 gets me to 12. And whatever I do to my denominator, I also have to do to my numerator. So 12 times 2 equals 24. So we're going to rename 12 sixths as 24 twelfths. And now we can really compare these two. The hungry alligator eats the fraction that is greater. So would that hungry alligator rather have 25 twelfths or 24 twelfths? 25 is more units than 24, so we'll point our alligator that way. So that's the first skill that we've practiced today, is comparing our fractions when they have different denominators or when they're in different forms. So let's switch to a different skill. Let's start adding together our mixed numbers. The first problem that we have is 6 4/10 plus 7 9/10. Last week, we practiced a strategy called add the parts. When I have 2 mixed numbers, sometimes it's easiest by just focusing on the whole number and the fractions separately. Meaning I could add just my 6 and my 7, then go back and add my 4/10 plus my 9/10, and combine those two sums together to see what I get. Let's start by adding 6 plus 7. And that equals 13. Now we'll add together those fractions. 4/10 plus 9/10. 4/10 plus 9/10 gives us a total of 13/10. I know that 13/10 is greater than 1 whole, so let's change that to a mixed number. I can pull out 10/10, 1 whole, and 3 more tenths. So I'm going to rename that as 1 and 3/10. All right, now that I've added my whole numbers, I've added my fractions, let's combine those two sums together and see what I get all together. 13 plus 1 and 3/10. 13 plus 1 is 14. And then my 3/10. And there's our answer. We can still use this strategy even when I have 3 add-ins, like in this problem right here. I have 3 whole numbers to combine and 3 fractions to combine. But I can still use the same strategy. I'll start by adding those whole numbers. 4 plus 6 plus 1. 4 plus 6 is 10, plus 1 more is 11. And now I'll put together those fractions. 1/8 plus 3/8 plus 7/8 equals 1 plus 3 is 4. 4 plus 7 is 11 for a total of 11/8. That's an improper fraction, so I'm going to break it into its mixed number. 8/8 and 3 more 8s, which gives me a total of 1 whole group and 3/8. So now I can combine these two sums together, the sum of my whole numbers and the sum of my fractions. 11 plus 1 and 3/8 for a total of 12 and 3/8. We've practiced comparing fractions. We've practiced adding fractions. Now let's practice multiplying a fraction with a whole number. Solve 3 times 5/8 right as a mixed number. When I multiply a whole number times a fraction, my units don't change. Oops, sorry. I'm still going to have 8s in my answer. I'm going to multiply my numerator times that whole number. 3 times 5 equals 15. Technically, I've solved the problem, but I can't stop here because it specifically wants my answer as a mixed number. So I've got to change 15/8 into a mixed number. I'm going to pull out one group of 8/8 and however many 8s are left over. 15/8 take away 8/8 leaves me with 7/8 for a total of 1 whole group and 7/8. So my answer is 1 and 7/8. So now we're going to be practicing a subtraction problem. When we were doing subtraction last week, we learned the arrow strategy, which makes it a little bit simpler to break down our numbers by making them more manageable. We're going to start with the first whole number that we have, 3 1/5. And we're going to take away just pieces of this mixed number at a time. The first thing I want to take away is my whole number. This whole number is -1, so I'm going to take away -1. 3 1/5 take away just 1 leaves me with 2 and 1/5. In a perfect world, my next step would be to only take away 1/5, because then I could get to the number 2. But here's the problem. I have 3/5 to take away. So we're going to decompose those 3/5. We're going to decompose it into the 1/5 that we want to take away and what's left over. 3/5 can be broken into that 1/5 that we want to take away and 2 more fifths. All right, so far I've taken away my 1, so I'm going to cross it out. I've decomposed my 3/5. So these are the last 2 fractions to take away, 1/5 and 2/5. Let's start with taking away that 1/5. 2 and 1/5, take away 1/5, leaves me with just the number 2. Okay, so I've taken away 1, 3/5, 1/5. All that's left for me to take away is 2/5. When I take away a fraction from a whole number, remember it's that whole number minus 1. 2 minus 1 is 1. And however many more we need to make one whole group from the fraction we're taking away. So if we're taking away 2/5, how many more fifths do we need to make 5/5, one whole group? That would be 3/5. So altogether, I have 1 and 3/5. For our last 2 problems today, we're going to analyze whether or not they are true or false. And if they're false, we're going to ask ourselves how we can fix it to become true. We have an addition statement and a multiplication statement. 3/5 equals 3 plus 1/5. Is this a true statement or is this a false statement? You might be looking at it and saying, false. If it is false, we're going to change it so that it's a true statement. And there's actually 2 ways that we can do this. What I notice is whoever wrote this statement, they were mixing up their addition and their multiplication rules when we have a whole number and a fraction. So we can fix this by correctly adding, or we can fix this by correctly multiplying. If we correctly added a whole number plus a fraction, 3 plus 1/5 would give us the mixed number 3 and 1/5. If we wanted to fix this through multiplication, we could say 3 times 1/5 equals 3/5. Both ones show the correct way to combine 3 and 1/5, either using multiplication or addition. Let's analyze the next one and see if it's true or false. You have a string of repeated addition of 1/8 equals 10 times 1/8. What they're asking is whether or not this repeated addition sentence shows 10 copies of 1/8. So we're going to count up and see if we have 10 of them. If we do have 10, it's true. If we don't have 10, it's false. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is true. And since it's true, we have no fixes to make. Now it's your turn to practice some problems in your classroom.